For this video, we have subtopic 5.3, vector product. At the end of the lesson, students should be able to find the vector product, properties of vector product, and the area of parallelogram. What is the vector product? Vector product, we call it as cross product. That means the answer must be in the form of vector. Dia mesti ada I, J, and K. What is the purpose of cross product? Cross product to find normal vector. Apa dia normal vector? Normal vector adalah satu vektor yang perpendicular terhadap vektor yang lain. Contoh, kita ada vektor A dan kita ada vektor B. Okey, kita ada vektor B. So, inilah yang kita panggil vektor normal. Okay, next, kita untuk cari area of parallelogram dan triangle. Dan seterusnya kita cari koordinat seperti midpoint, distance dan lain-lain lagi. If theta is angle between vector A and B, then A cross B is equal to magnitude A dot magnitude B multiply with sin theta and multiply with unit vector. Actually, this is a unit vector, okay? Unit vector that perpendicular. Okay, unit vector that perpendicular to both vector A and B, or we call it as vector normal. Normal vector tadi. So we can find unit vector normal by using A cross B over magnitude A cross B. Disebabkan vector product is vector, that means we have the direction. Okay, so how to find in the direction of cross product A cross B? We can find the direction by using right hand rule, where the finger turns A to B and then the thumb points in the direction A cross B. Okay, untuk matematik, kita kadang-kadang boleh dapat satu positif, satu negatif sebab kadang-kadang 2 point. So, kita tahu dia positif atau negatif. Tetapi, both is same. Okay? Dua-dua sama. Sebab kita tahu, kalau kita cross product dua vektor, okay, such as like this, A cross B, A to B, we can get A cross B. Dia naik ke atas positif. Kadang-kadang soalan kita tu dia boleh dapat negatif kepada normal vector yang pertama. So sama je, dua-dua jawapan tu boleh diterima. Alright, cuma beza dia ada negatif. Okay, ni contoh. Katalah kita ada 3 dimension, 3 dimensi. So, katalah ini X, Y dan Z. Dan kita biasa tahu kan, untuk 3 dimensi ni mestilah perpendicular to each other. So, bila kita crosskan, I cross J, kita akan dapat K. Ingat sebab dia perpendicular. Cuma, the direction mesti IJ dapat K. JK dapat I. Dan sebaliknya lah. Okey, tapi katalah kita tukar. Tukar direction. I cross K. Kita tukar direction. So, we can get negative J. Okey, negative J. Dan seterusnya lah. Okey, next. How to calculate vector product by using determinant. Okay. Let's say we have A and B. So, kita nak cari tu boleh gunakan determinant of matrices. Macam matrices tu by using first row. Okay, by using first row. Kita eliminate first row and then kita darab macam biasalah nak cari determinant. So untuk kes ni macam biasa saya selalu ajar student saya, mula-mula kita letak I. Sebab ingat dia ada positif, dia ada negatif, dia ada positif. So untuk I dia positif, untuk J dia negatif. So minus J plus K. So apa yang kita nak darabkan pula kat sini? So darabkan ni ingat lagi kan yang kita kena eliminate tu. So kalau kita I eliminate yang ini, so yang tinggal tengah-tengah ni. Apa nak buat tengah-tengah ni? Apa nak buat tengah-tengah ni? Determinant 2 kali 2 dia pula. Maksudnya yang darab silang. So kita ada A2 B3 minus A3. Okay, tak mau pula. Minus A3 B2 I. Okay. Samalah macam yang lain So kita dapatlah tolak A1 B3 minus A3 B1J plus A1 B2 minus A2 B1K. Okay, so tak payah hafal pun tak apa. Ingat balik dia mesti sama cara dia nak cari determinant by using first row. Okay, next. Properties of vector product. So macam tadi kita dah tunjukkan menggunakan normal vector kita boleh tahu A cross B must be equal to negative B cross A. And then kalau ada scalar yang kita darabkan dengan vektor produk tersebut, kita boleh ubah-ubah tempat dia lah. Mungkin M tu kita keluarkan dulu, kita crosskan AB dan seterusnya. C, katalah kita ada dua vektor yang kita plus. Kita nak cross product di depan di depan. Itu kat depan. So, dia akan jadi A cross B plus A cross C. Kat depan lah. Kalau kat belakang, dia mesti duduk belakang. A cross C, A, C belakang. And then B cross C pun dekat belakang. Alright. Okay. E dot product. So, untuk dot product, kena ingatlah dia boleh dua sahaja. Sama ada A dot B, A dot hasil B cross C ataupun A cross B dot C. Itu sahaja kita boleh ubah. Okay. F, kalau kita cross tiga vektor, A cross B cross C, hasil dia akan jadi A dot C times B minus A dot B times C. Okay. And then kita ada satu lagi properties. A cross B equal to 0 if A and B are parallel. Sebab ingat bila kita cross tadi kita dapat normal kan. Normal maksudnya perpendicular. Okay. Perpendicular. Dia 90 darjah kan. That's why kalau dia bila kita cross, kita dapat 0 means dia parallel lah. Okay. Dia tak jadi perpendicular. Alright.
Applications of the vector product. Area of the parallelogram. To find it, we just need to find a magnitude of A cross B. And the area of triangle. Triangle, you can get it from half of the parallelogram. So, to find the area, half of magnitude A cross B. Okay. Example 13. We have two vector here. We need to find the vector normal of A and B. In simple saja. A cross B is equal to Ki, J and K. And then please remember, if we want to put A, we put it here. And then B, we put it below here. Okay? Then A is 2, 3, negative 2. J is 4, negative 2, and 3. Alright, now to find the vector product, okay, I try to put it here. We have blah 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 I, then negative blah 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 J plus K. Alright, I. If you close the I part, we get the value is 9 minus 4. Okay, how to get the 9 minus 4? Here, if you close I part, 3 times 3 minus negative 2 times negative 2, you get 9 minus 4. And then we go to the J part. Okay, for the J part, if you close the J part, you get 2 times 3 equal to 6. So 6 minus 4 times negative 2, you get negative 8. Is it true? Okay, try to close the J. I cannot close it first because if I try to and I cannot close it first. I need to close it later. Alright, if you close it J, we get 2 times 3, 6. Kan, betul kan? And then how about the K part? If you close K, you get negative 4 minus 12. Betul. Try to close it. 2 times negative 2, we get negative 4. And minus 4 times 12, we get 12. Minus 12. Okay. So everything is equal to 5i. 6 times 8 equal to 14 minus 14j. Then negative 4 minus 12 equal to negative 16k. Example 14. Given vector A, I plus 2j plus 3k and vector B, negative I plus 3j minus k. Show that A cross B equal to negative B cross A. Okay. So A cross B, we need to use a larger space. So, okay, I try to write it down here. Okay, A cross B equal to, okay, I, J, and K. And we have 1, 2, 3, negative 1, 3, negative 1. And then we get I, J, K here, negative here. Okay, and then we have okay, if we close I, then you get negative 2 minus 9, right? Negative 2 minus 9i, negative 2 minus 9. Okay, if you close the I part, right? Negative 2 minus 9i. And then, if you close J, you get negative 1 minus negative 3, right? Negative 1 minus negative 3. And then plus 3k. Okay, negative 1 minus negative 3. And then for the K part, we have, okay, for the K part, you will get, if you close the K part, you get 3 minus negative 2. Okay, and then it's plus sign here. Alright, and then we put everything in one line. You get negative 11i minus negative 1 plus 3, you get negative 2j. and then plus 5k. Okay, we try to find B cross A. Okay, remember, if A is here, then A should be the first one that we write down the vector. Then B will be below here. Okay, if you interchange, then the value will not be similar. Maybe we should put the negative sign. So here, that's the thing that we want to see. Okay, now we make a line here, not a good line, but I try to make it better if it is possible. Alright, now we go to negative B cross A. So we try to find B cross A. Okay, B cross A, B cross A. Okay, the same thing, I, J, and K. So B should be the first one that we write down, -1, 3, -1, and A should be below it, 1, 2, and 3. Okay, equal to, what do we have here? You close the I part, we get, you close the I part, okay, you close the I part, you close the I part, you close the I part. Okay, try to write down first. What do we have? J, I, J, and K. Okay, and then we have here, if you close the I part, we get 9 minus -2. And then for the J part, if you close the J part, we get -3 minus -1. And then if you close the K part, you get -2 minus 3. Okay, -2 minus 3. So we put everything in one line. You will get, here should be positive. So 11i, okay, minus 3 plus 1 equal to -2. Multiply by negative become positive 2j minus 5k. Okay, it's similar, right? So show that AB equal to negative B cross A cross B equal to, so how to write it down? If the question asks us to show, so we need to state at least one word here. Oh no, one word. One ayat. Kan satu ayat. Ayat because sentence. So show that A cross B. A cross B is equal to negative B cross A. Okay, that's for the A part. And then for the B part, prove that A cross B is a vector which is perpendicular to the vector A. So we know that for a perpendicular vector, the dot product must be equal to 0. So in this case, we need to prove that either A cross B dot vector A is equal to 0. Okay, so maybe you can make vice versa, vector A dot A cross B equal to 0. We can try, but I try this one first. So vector A cross B dot A equal to 0. We need to prove that vector A cross vector B dot vector A equal to 0. That's the thing that we need to prove. So we try to find out. Vector A cross B is equal to what? A cross B, we get A cross B and not B cross A. A cross B is equal to, we put it in a matrix form, -11, -2, and then 5, dot with vector A. Vector is 1, 2, and 3. So we get negative 11 plus negative 4 minus 4 lah. And then plus 15. So we get equal to 0. If you make it vice versa also, it will be the same. It still will be 1 times negative 11 plus 2 times negative 2 plus 3 times 5. Okay, because b dot a equal to a dot b, right? So it's similar. So show since. Okay, now we make it in a sentence because the question asks us to prove or show. So we need to end the way we answer this question with one sentence at least. So we state it here. Since A cross B dot A equal to 0, therefore also A cross B is perpendicular to vector A. That's it. Okay, now we go to example 15. I'm sorry if the way of writing or my handwriting is quite bad. I'm so sorry about that. Okay, we go to example 15. As long as you can see and you can understand, that's good already. I hope so. Now we go to example 15. Find all vectors of length 11 units which are perpendicular to both A and B. Alright, so a vector that is perpendicular, a vector which are perpendicular to both A and B is a vector that is perpendicular to both A and B is a vector that is in the direction of the cross product A and B. So meaning here we need to do a cross product. Okay, a cross product of A and B. So we find cross product first. A cross B equal to I, J, K. Okay, 1, 2 and negative 1. 1, 0, negative 3. Right. Then we have I, J, then K. Here should be negative and here should be positive. Okay. Oh my god. Now the meow things. Oh, very the bising lah. Now you close the iPad, you get negative 6, right? Negative 6 minus 0, negative 6 je lah. And then if you close the J part, okay, you close the J part, you get negative 3 plus 1. Okay, right, negative 3 plus 1. And then you close the K part, you get 0 minus 2. Okay, and then make it in one line. You get negative 6i plus 2j minus 2k. Am I correct? Negative 6i plus 2j minus 2k. Okay. And then after that, we need to find the magnitude of the cross product. Okay. The magnitude of the cross product. Because, okay, I will tell you later why we want to find the magnitude of the cross product. The magnitude of the cross product A cross B equal to A square plus B square plus C square, the set of everything, negative 6 square plus 2 square plus negative 2 square. Set, you get set 44, which is equal to, if you try to calculate by using calculator, 44 is equal to 4 times 11. So we get the answer is 2 times set 11. Okay, 2 times set 11. And then, okay, let U be a unit vector which are perpendicular to both A and B. Okay, so we need to find the unit vector. Why we want to find the unit vector? Because the question asks us to find all vectors of length 11 units. Okay, so we need to find a vector that is in the direction of the unit vector. Okay, if it involves thing like this, we need to know that any vector of length 11 in the direction of the unit vector will be perpendicular to both vector A and vector B. So we need to find the unit vector so that we can multiply with the length 11. So any vectors that with that length multiply with the unit vector is perpendicular with both vector A and B. Okay, that's the thing. So we need to find the unit vector. We need to find the unit vector. So I try to make a line here. I think it should be easy to make a line here, but I don't know how. I'm sorry about that. Okay, and then unit vector. Okay, we try to let U hat be a unit vector. Be a unit vector which are perpendicular to both vector A and B. Okay, therefore we need to find the unit vector. U hat is equal to, remember, unit vector is the vector divided by the magnitude. Okay. And then we need to put the plus minus sign. Why we need to put the plus minus sign? Because a unit vector can be both positive and negative. Okay, as long as it is in that direction. Because unit vector, it represents direction, not magnitude. Okay, so it can be negative and positive. So this one equal to plus minus negative 6i plus 2j minus 2k divided by magnitude 2 sed 11. Okay. Here is the unit vector. Okay. We need to put the plus minus in front of the unit vector because we want to find all vectors. All vectors that is in the direction of the unit vector. Okay, either positive or negative. Either in the same direction or the opposite direction. That's the thing. And then, we are not answering the question yet. We are still not answering the question. Because the question asks us find all vectors of length 11. So here, the last part is we need to multiply this unit vector with 11. Okay, vectors of length 11 which are perpendicular to both A and B are, okay, we need to multiply sed 11. Sed 11 multiplied by U hat is equal to sed 11 multiplied by plus minus negative 6i plus 2j minus 2k divided by 2 times sed 11. Oops. Okay. So equal to, you will get two answer, which is for the positive part, you will get negative 3i plus j minus k Or for the negative part, you will get 3i minus j plus k. Okay, one for the positive part and one for the negative part. That's all for this example 15. It's quite long, but yeah, try to take time to understand this kind of question. Okay, hope you can do it. Example 16, given vector A equal to 2i minus j plus 4k and vector B negative 6i plus 3j minus 12k. By using the vector product, show that vector A and B are parallel. So, okay, we know that if we use vector product, okay, vector product, let's say we have vector A here, vector B here, okay. If we use vector product, then vector product of these two, A cross B, we will get normal vector. Okay, normal vector. Normal vector which is perpendicular. Okay, therefore, to show that if we have a value for A cross B, meaning they have a normal vector perpendicular to each other, but then to show that A and B are parallel, so meaning we need to show that if parallel if A cross B equal to 0. Okay, if we use vector product, then we can show that A cross B equal to 0. Let's show this, that two vector is parallel to one another. Okay, this one parallel like this. This is perpendicular. So by using vector product, we just simply use vector product. A cross B is equal to, we have I here, J here, and then K here. I, J, K to negative 1 and then 4, negative 6, 3, negative 12. Okay, equal to, okay, we close the I part. Okay, you close the I part. Then I, J, K here. Plus, minus, plus. Okay. You want to show us the value that we get inside here. Okay, if you close the I part, you will get negative, sorry, you get 12 minus 12, right? 12 minus 12. Here. 12 minus 12. And then, if you close the J part, you get 24, negative 24 plus 24. Negative 24 plus 24. Okay, negative 24 plus 24. And then, if you close the K part, you will get 6. Is it 6 minus 6? Okay, 6 minus 6. Therefore, if we put it in just one line, we get 0i minus 0j plus 0k, which is equal to 0. Okay, we need to put it in one sentence. Since vector A cross vector B equal to 0, therefore vector A and vector B are parallel. Alright. Now we go to example 7. Example 7, a plane contains points A, B, C, and D. If A, B, C, and D forms a parallelogram, Find the coordinates of D. We need to draw it first so that we can see what we are talking about. We have a plane. Okay, wow, very big plane here. Let's say we have A here, B here, C here, and then D here. So for a parallelogram, then AB must be, the vector of AB must be equal to DC. And then AD must equal to BC. And then what's similar between these two vectors, AC and BD, they should have the same midpoint. Okay, where is the midpoint? Here is the midpoint. Okay, midpoint here. So now we need to find what is the points for D. Okay, we have A 1, -4, 2, and then B is 1, 1, 1, C is 3, 2, -1, and D we name it as alpha, beta, and gamma. Okay, we know they should have similar midpoint, AC and BD. Okay, so midpoint of AC, okay, we write down here. Midpoint AC must be equal to midpoint AC equal to, okay, if A go to C like this, then it must be equal to BD. Okay, midpoint BD. Right, how to find midpoint for AC? This is pengetahuan sedia ada lah. We call it as pengetahuan sedia ada. 1 plus 3 divided by 2, -4 plus 2 divided by 2, and then 2 minus 1 divided by 2. What about midpoint for BD? Okay, equal to midpoint BD. So 1 plus alpha divided by 2, and then beta plus 1, or 1 plus beta divided by 2, last one gamma plus 1 divided by 2, or 1 plus gamma divided by 2, similar lah. So we can compare that to 1 plus 3 divided by 2 must be equal to for alpha. Okay, we try to find one by comparing. Okay, by comparing to find alpha. Okay, alpha is equal to, don't have to write down the alpha part lah. 4/2 equal to 1 plus alpha divided by 2. Therefore, we can get here alpha is equal to 3. Okay, alpha equal to 3. And then -4 plus 2 equal to -2, right? -2, -4 plus 2, -4 plus 2, so -2/2 equal to beta plus 1/2. So we get beta equal to -3. And for gamma, gamma plus 1/2 is equal to 1/2. So we get our gamma is equal to 0. Alright. Therefore, we get our point D. The point is 3, -3, and 0. That's the answer. Okay, now we go to B part. The area of the parallelogram AB, CD. Okay, we want to find the area, right? The area of the parallelogram. The formula to find the area of parallelogram is just cross vector, magnitude of the cross vector between two vectors. Okay, now we want to know what vector that we want to take here. So normally we should start from the same starting point. Okay, let's say here let's say we have a point A here. The point is 1, -4 and 2. Then we have point B here, which is 1, 1 and 1. Then we have point C here, which is 3, 2 and -1. So we will try to find what's the vector from this starting point. This is our starting point, B. So from here, we need to find what's the vector for BA, right? BA here. And then this is BC. Okay, so vector BA, vector for BA is A minus B. Okay, A minus B, 1, -4, 2. B. A minus B, right? A minus B. Okay, the last position vector minus by the initial position vector. B is 1, 1, 1. So we have AB is equal to 0, -5 and 1. And then for BC is C minus B. Okay, 3, 2, -1, minus 1, 1, 1. We get 2, 1, and then -2. Okay, now we need to find the cross product of AB and BC. AB cross BC. BA cross BC. BA cross BC equal to I, J, K, 0, -5 and 1, 2, 1, -2. Okay, equal to I, J, K, plus minus plus here. Okay, just the same process for cross product. We close the I part, we get 10 minus 1. 10 minus 1. And then we close the J part, we get 0 minus 2. Right? 0 minus 2. So here we have minus 2. And then for the K part, we get positive 10. Okay, positive 10. So what we'll have here is -9 plus 2 and plus 10. Overall is 9i plus 2j plus 10k. So the area for the parallelogram is area of ABCD equal to magnitude vector AB cross BA cross BC, BA cross BC is equal to 9 square plus 2 square plus 10 square. Okay, square root of everything. So we get the answer is 13.6 units square. Example 18. A plane contains points A, B, and C. Find a vector normal to the plane. Vector normal to the plane. Okay, so for these 3 points, we need to take whichever point to take that point as an initial point. Okay, let's say I am interested to take point A as my initial point. So let's say this is my A, then here is B, here is C. Okay, or let's say because we want to, this is a plane, a 3D, right? Okay, we try to redraw, make it like a 3D. Okay, this is my A here. A. This is B. This is C. A is 1, 1, 0. And then B is 3, negative 2, 1. My C is 5, 7, 2. If we cross AB and also AC, we will find the and here normal vector for AB and AC. Okay, direction vector AB. So direction vector AB means B minus A. So B is 3, negative 2, 1. My A is 1, 1, 0. We get the direction vector is 2, negative 3, 1. And then we find the AC. C meaning C minus A. C is 5, 7, 2 minus 1, 1, 0. Here we have 4, 6, 2. Okay, and we cross product that too. AB cross AC. AB cross AC. So that is our normal vector. Normal vector is equal to plus minus AB cross AC. We want to find a normal vector, right? Not the magnitude of it yet. Normal vector, it can be positive or it can be negative. It can be either in the same direction or opposite direction. Okay, here is also N. Okay, either one is accepted. Okay, so we should have 2 choices, either positive or negative. Right, so plus minus. How to find AB cross AC? I, J, and then K. Okay, AB should be, we should write that first. 2, negative 3, and 1. 4, 6, 2. We get. Okay, now what's the value for everything? Plus minus. If we close the I part, okay, the I part, you close the I part, you get negative 6 minus 6, which is negative 12i. Then negative. If you close the J part, you get 4 minus by 4, right? Negative 4 minus 4, which is 0. Okay, 0J. Plus, you close the K part, you get 12 minus by plus minus by negative 12. So you get 12 plus 12, which is the value that it gives you is 24. Okay. Okay, so we have plus minus here, which is equal to plus minus negative 12i plus 24k. So you will have to vector normal to the plane, which is either negative 12i plus 24k or 12i minus 24k. Okay, that's the two normal to the plane, either the positive part or negative part, either in the same direction of the plane or in opposite direction of the plane. Okay, now we go to the area of triangle A, B and C. Area of triangle is half of the area of parallelogram. It's simple. We have AB cross AC already, right? We already find AB cross AC, which is equal to negative 12i plus 24k. Therefore, our area of triangle ABC is equal to magnitude of vector AB cross AC equal to AB cross AC magnitude of negative 12i plus 24k equal to negative 12 square plus 24 square. Oh, sorry, it should be half here. Half multiplied by negative 12 square plus 24 square. So we get the answer is 13.42 units square. Okay, that's all for example 18.